Hello students, welcome to the series Microwind Layout Analysis, wherein we'll learn how to analyze the layout made in Microwind to justify the truth table or functionality of the proposed digital system. But before we go from one layout to another analyzing it, let us understand the device or system basics, which are as follows. To the right we see we have a PMOS and an NMOS. PMOS is an active low device, which means when logic 0 is applied to the gate, it turns on. So when I apply a logic 0 to the gate of PMOS, PMOS turns on. On the other hand, if I apply a logic 1 at the gate, the device turns off. On the other hand, NMOS is an active high device, which means when I apply a logic 1 at the gate of NMOS, it will turn on. That means if I apply a logic 1 to the gate of NMOS, NMOS turns on. On the other hand, if I apply a logic 0 at the gate, the device will turn off. Now we have different systems: PMOS, NMOS, transmission gate and CMOS inverter. And we will see that if logic 1 and 0 are applied to each of the systems, what output do we get? Consider a PMOS. Assume that logic 0 is applied to the gate of PMOS and hence the PMOS is turned on. If I apply a logic 1 at the drain of PMOS, I obtain a strong 1 at the source, which is acceptable. On the other hand, if I apply a logic 0 to the drain of PMOS, I obtain a weak 0 at the output, which is not acceptable. If I apply a logic 1 to the drain of NMOS, I obtain a weak 1, which is not acceptable. While if I apply a logic 0 at the drain of NMOS, I obtain a strong 0, which is acceptable. Transmission gate, it is a PMOS parallel NMOS. That means a transmission gate is a pure CMOS system, and hence it is expected to deliver both strong 1 and strong 0 at the output. So if I apply a logic 1 at the input node of a transmission gate, it will transmit it as a strong 1, which is acceptable. If I apply a logic 0 at the input node of a transmission gate, it is transmitted as strong 0, which is again acceptable. Coming to CMOS inverter, it is an inverter. That means it must convert a logic 1 to a logic 0 and a logic 0 to a logic 1. But because it is a CMOS inverter, it translates or it converts logic 1 at its input into strong 0 at its output, which is acceptable. And if I apply a logic 0 at the input of a CMOS inverter, it translates it as strong 1, which is acceptable. So strong values are acceptable and weak values are not acceptable, right? So weak values at output are not acceptable. To summarize it, PMOS is an active low device, which means when 0 is applied at the gate, of PMOS, it turns on. NMOS is an active high device, which means if a logic 0 is applied at its gate, it turns on. A PMOS gives a strong 1 and a weak 0. NMOS gives a weak 1 and a strong 0. Transmission gate, it transmits 1 as strong 1, 0 as strong 0, both of which are acceptable. CMOS inverter converts 1 into strong 0 and a 0 into strong 1, which is also acceptable. Thank you very much.